Here we have an HP Spectre laptop that came in for no power. The customer is not able to power the laptop on. Big Boss already attempted to charge the laptop, power it on, change the battery and all that good stuff, and the laptop is dead. Now the laptop is showing 20 volts, 0 amps. The laptop is not taking any amperage, but it is showing 20 volts. 20 volts is good, but 0 amps is not good. So we already disassembled the board and we have it right here. And let's take a look. Now the fact that we have 20 volts, I know that our USB-C controllers are good, but we never know. We have a USB-C connector here and we have one here. While doing visual inspection, let's also measure. And the diode is good. Now on few occasions, for different customers, we had to replace this chip because of a short here or a short here. Now look at this, we have a short here. A short here is not good because it could be directly related to the CPU or this chip here. Let's continue with visual inspection. And look at that. This does not look good, and I do not believe this is adhesive or glue. Yeah, the chip is fried. The chip is fried. And we do see, oh, okay, it's fried and we have a burned trace. So this chip may be what's causing the short here. And then we have our USB-C controllers, and I do not think the problem is our USB-C controllers because we do see 20 volts. Let's continue with visual inspection. Right now, honestly, I do not want to replace anything on the board unless we take care of this first, and then we can continue measuring if the laptop still does not work. But right now, I'm not interested in measuring MOSFETs or whatever the case may be, because this chip here may cause many things on the board to measure faulty. So what's this chip? I do have a donor board right next to me, the same exact donor board. We work on those laptops every single day. And this is a TUSB546D. What's TUSB546D? It's a redriver cross-point switch. So it has something to do with the USB-C connectors. And this chip may have went bad because of something bad that was plugged into the USB-C connector, or maybe a bad charger. Or even if the pins are damaged on the USB-C connectors and they are shorting out, they can cause this chip to go bad. Let's take a quick look. And just like I suspected, we may have a problem with this connector. Because right now, even if we replace that chip, it may blow again because of a problem, a possible problem with this connector. I mean, if you look here, we do see damage. And if we look here, we see a slight damage. It looks like the customer's charger, the connector on the charger is not good. And it damaged both of them, or at least this one here. This does not look too bad, but this one looks damaged. Let's remove that connector. And now we're going to replace the chip. Now we do have a problem with one of the traces right here. Why not just get rid of this? And we're gonna use our grinding pen. Just like that. And we're gonna grab a strip pad, and I have strip pads number 2. You can find those on our website along with the grinding pen, along with Flux and all the tools that we use in the shop here. I keep mentioning this because in every video we have somebody asking, what's that tweezer that you are using? What's that pad strip that you're using? Where do you buy the grinding pen? We have everything on our website, and everything is in stock and ships out same day or the next day. It depends on the cut-off hours. For our regular viewers, they probably get annoyed because I always mention it, but I'm doing this for new viewers, and just bear with me. And we're gonna cure this with our 10 watts UV lamp. And we just have that shiny surface on top. We can just expose it to a little bit of hot air, and that shiny surface disappears. I went over that trick in a previous video where I showed you how hot air can help with the curing of solder mask. Luckily the 10 watt UV lamp is able to cure mask just fine, but you are left with that shiny surface that you can get rid of when you apply a tiny bit of hot air. Let's thin that pad, because if we do not apply solder onto it, then the chip is not going to make a good connection with the wire. And we're good. All right, and we are all set. Let's clean up, and we'll see. Do you have a short here? And yes, we do. We do. Now the short is not coming from the capacitor itself. I know this from experience, but let's take out the cap and measure it, since it's easy to do so. Is the cap shorted? We're gonna measure in continuity mode. It's never the case, but why not do it? And the cap is not shortened to ground. So right now we're gonna remove the chip. If the short is gone, then the problem is the chip. And the chip is out. The chip is out. Let's see, do we still have a short? And we still have a short. We're gonna inject voltage at the shorted area of the cap, and we're gonna see what gets hot on the board. But from experience, I know a short here is likely caused by the CPU. A lot of you may ask, why not replace the CPU? And I always answer, it's neither practical nor economical to replace the CPU. If we did find a used CPU, it's gonna be a lot of money. And when you are buying a used CPU, you do not know if that CPU is good to begin with. Maybe we are buying a faulty CPU advertised as being good. Once you rebel and solder that chip on the board, it doesn't work, you cannot send it back because it's already a used chip. So neither practical nor economical. If the problem is the CPU, then we deem the repair a no fix, the device a no fix, and we send it back to the customer. Unless the customer doesn't want it, then we can use it as a donor for future repairs. And that's how we have a lot of devices in the shop here, a lot of donor devices. Right, so we're gonna inject voltage at the shorted area of the cap and we're gonna see what gets hot. Let's switch over to our thermal camera. We have a 0.85 amp draw, which is not much, right there. Our CPU is getting hot. I'm injecting 1.2 volts and amps being drawn 0.84 and our CPU is getting hot. A heat spot on the CPU does not mean the CPU is bad, but from my experience working on this model laptop, I've seen it a lot. What we're gonna do is we're gonna check our VCore MOSFETs, and we have a lot of MOSFETs located under this metal shield here. There were times where I've spent 2, 3, 4 hours working on this model board. I can tell if it's gonna be a CPU problem or not a CPU problem based on my experience working on those boards. So let's take a look at those MOSFETs. And we are reading 17 ohms on gate. And that's very, very, very low. What about if we look here? 449 ohms. 445 ohms. And we have a short here. Now, I'm not going to go through this again because I've done it before where I replaced this MOSFET and that MOSFET, and then we ended up going all the way to the top here, and we also had bad MOSFETs on the top. Let me verify this. And look at this. Same exact problem I've experienced before. Now, I knew this from the beginning. A short circuit on that capacitor is likely due to the CPU because I worked on that very same issue many times, and it's almost always exactly the same where we have bad MOSFETs on the bottom, bad MOSFETs on the top. I replaced those MOSFETs on the bottom, on the top, and then same problem where the laptop is not working. I'm not going to go over replacing all the MOSFETs because I've done it many times before. And that's it. It's a no fix. I hope you enjoyed the video. Don't forget to like and subscribe, and we'll do something else in the next video.